So hello everyone. I'm going to talk about the ICP10 as a part of Python and deep learning. My name is Prabhanjan, and as a part of this ICP, our first question was like we have to find the three mistakes in the given code. So the code was already provided, and I am doing it into the Google Colab. So first we imported all the libraries here as the first part of the code, and then we have to do the data analysis on the IMD master CSV file. So I have uploaded that file. uh, I downloaded that file, and to upload that one into the Google Colab I use this one. Like, I can run this one. So all the library has been imported, and then after running this one it will ask me which file you want to upload. So I can choose a file from here, and here is our IMDb master CSV file. I will open it, and it's a little bit longer file, so it will take a little bit time. So I have already done it, so I will go through the code, and I will see how it's working. So if you'll see it here, like it's 1% done. It takes a little bit time to create the data into the Google Colab. So then I'm reading here the file. If you'll see the file here, we have around 100,000 record, and all are non-value, and we have a column like type, review, label, and then the file name. So this is the basic information about the file. And if here, this is what I'm printing, the first row of the data. So we have unnamed here, then we have a type, and here we have a review, then we have a label, and then we have a file name here. So we have to do a categorical analysis. Like, we have to create a model in which it will read about the review and it will predict about the label. So here we are taking the only the review column and the label column. So review is our feature, and call label is our target value. So so we have come up here like sentence and why. So sentence will have a feature, why is the target. So now we have to because sentence is like the list of the words, so we have to make it into the way in which the system can understand it. So here we have tokenized the data. So number of words, we have taken the 2000, and then fit the data into the text. So we are passing sentence into, and it will fit on the text. And here we are changing the text to the matrix. So the first line here, tokenizer, it is nothing but this is just the object creating. Then we are sending the sentence as input into the tokenizer, and it will fit the sentence into this object tokenizer. And then we are changing text to matrix by passing the sentence. So we'll get a matrix. So basically it will nothing but it will be the numbers, and each number will correspond to a words. And if we want to see it here, like uh, as we have seen, we have 100,000 of total number of row in the data. So we have 100,000 as a row in the data set, and each sentence will have a 2000, because we have defined the word number of words into 2000 during the creating the tokenizer object. And then for the why, we have done the pre-processing, like we have done the hot coding for it, and then we have created a mod. Then we have split the data into the train and test, with 25% data taking as a test data. And here we have to pass. So once we will create the model, we have to pass the input shape. So if you see the input shape, we have an input shape to the model is a 2000, because each row into the data, it has a 2000 index. So and the shape of output layer, like in the output layer we have a three value, 0, 1 and 2. So output layer will have a 3, so we have to predict 3 value, one value out of the 3 for each input. So this is the model which we got. So our the first correction is here, like the input dim was not defined, so we have defined the input dim as 2000, or we can say we can take the extend, and we have taken the shape of first record. and which is nothing but a 2000. And here the output of the dense layer will be like this is the output layer. So for the output here, it should not be 5. Earlier it was 5, so we change it to 3. And for the output layer, activation should be the softmax. It cannot be the ReLU, so I change that one to the softmax. So then we compile the model with epoch 5, and so this is the output. And I also plotted the graph for the fitting. It's across the training and validation loss. So this is for accuracy and this is for the loss. So we'll see, like for the training data we have a good accuracy, but it's not doing good over the validation data. At the same time, uh, on the loss we don't have a good a result on the validation data, because in the case of validation data loss is increasing, but in the case of training the loss is decreasing. So we can say like either this model is overfitted or this model is really not good because it's not performing well on the validation data. And here I have done the prediction over the test data. Like I've taken the first test data by passing the index value 0, and the actual value of this one is 2, and after the predicting I got the value is 2. So at least for this particular data it's working fine. Then the second layer, second question, as the part of second question, we have to embed the layer. We have to use the embedding layer in our model, because in this model we don't have used any embedding layer. So in the case of embedding layer, first I have taken the sentence and y, like sentence is nothing but a feature, y is our target value. Then we have done the tokenization of the data here, the same way we did for the model 1. And here we are getting the maximum review length, like how much maximum review length could be, and the vocab size, because for the embedding layers we need these inputs. So vocab size is nothing but like we have to take the length of tokenizer word index and plus 1. It will give us the vocabulary size, and maximum review length will be we have to split the sentences into s. So we have to find out what is the maximum length of any review. Then in this case we don't have to change text to matrix. In this case we have to change to text to sequence. And then we have to pad the doc. So if any record which is of course will be less than the maximum length, then we have to pad it either way. So padding will happen with the 0, so we'll add the 0 so that all the inputs will have the same length. And here we are doing the encoding for the target, and here we are splitting the data. And here I have created the model 2 with the name model 2, the same type of a model, but I have added the embedding layer here with the vocab size 50, sorry, with the vocab size, the number of layers 50, input length is equal to maximum review length. And of course output layer will have a 3 as a number of neurons. So then I have compiled and fitting the model. So this is our compiled this is the result of our epoch. So I have given the 5 epochs here, and then we have plotted the data. So again, like I was not able to get more accuracy if you compare with the model 1, but there is a little bit accuracy, um, but there is not much more achievement after doing the embedding. There could be a lot of uh, reason behind it, like we have to do a lot of epochs, not just 5, and we also have to, we could have used like 512 or something like for the number of neurons here, so that it will be better. So this was the part of question number 2, and also I have predicted the one value from the test data. And in the part of the question number 3, we have to do the same analysis for the different data set, that was like fetch 20 new groups. So here I have imported the data set from the sklearn dataset, and dataset name is the fetch 20 new groups. So here I have defined the two categories, one science space and one is atheism. And based on this category I am downloading the data. So I will get the data into the news group train variable. So here is the downloaded data. So again I'm doing the same thing. I'm taking the data into the sentence and y is all the targets, and while printing the target value I'm getting the 0 and 1. So we have a two target value here. So I've done the tokenization, I've done the all the preparation for the embedding layer here. Then I'm doing the here. So our features had been padded here with the padded docs. So I have an input as a padded docs for the model, and here I have hot encoded the out target value, and then I'm splitting the data and I'm getting the result after splitting into the X train X test, Y train Y test. So in this model I have created, I have used the same parameter which was the part of this ICP, and I have changed the output layer as 2 here because we know it's a binary classification we have to do. And then I have compiled the model, and this is like our epoch train data while fitting the model. And then I have plotted the graph. So the blue one is for the validation accuracy, and the green one is for training accuracy. And here the green one is for training loss and the blue one is for the validation loss. And then I have predicted the data. I have predicted for one value into this model. So in this case it's work like coming 0 and 0 for both like the actual and predicted value, but it could differ because we don't have a very good accuracy on this model. So this is the part of ICP10 which has been created by me. Thank you.